working on a hydrogen bromine membraneless flow battery. So what is this? So this flow battery, you could also think of it like a reversible fuel cell, but this flow battery, it operates in two directions. In one direction, you flow in hydrogen and bromine, and you yield useful energy, waste heat, and hydrobromic acid. In the opposite direction, you flow in hydrobromic acid and you yield hydrogen and bromine. Now, why is this significant? For a couple of reasons. One, bromine is an oxidant, and bromine is actually one of two elements that are liquids at room temperature. The other is mercury. So pure bromine is a liquid. So let's say if we wanted to compare this to a hydrogen oxygen or hydrogen air fuel cell. Oxygen, in order to get a high concentration of it, you'd have to compress it. So you'd need a large compressed gas tank. Bromine is just a liquid. So you can easily dissolve it in water or in hydrobromic acid at very high concentration. And so this gives you the potential for a very compact device. Also, bromine, the reactions with bromine are very fast. So because these reactions are fast, they're very low, there's very low heat loss and other losses associated with these reactions. So you get a lot of energy out for the amount of bromine that you put in. And so what this allows you to do is to have a system that's very high power density. So we've been able to demonstrate some of the highest power densities of any electrochemical system of any chemistry. And so the fact that we have high power density means that if you need a 1 kilowatt system, our box is going to be smaller because our power density is higher. So if you're at 1 watt per centimeter squared compared to half a watt per centimeter squared, you can be twice as small. And so the fact that we're high power density will allow us to make smaller devices. Smaller devices mean lower costs. So this hydrogen bromine system has the potential to be a low cost energy storage device. And people have known about hydrogen and bromine, back to something we talked about earlier about innovation. People have known about hydrogen and bromine for decades. GE explored these in the 70s. The issue has been devising an electrolyte membrane that would allow the hydrogen oxidation reactions and the bromine reduction reactions to occur over long periods of time and in a reliable manner. And so you create hydrobromic acid, and this hydrobromic acid is problematic for most membranes. What we've done that's innovative is we've actually designed a system that has no membrane at all. And so we use fluid mechanics in order to separate the reactions at the anode and the cathode. This is significant for a couple reasons. One, many of the things limiting this hydrogen bromine chemistry in the past were these membranes that I discussed that have difficulty with hydrobromic acid. So you have the potential for longer durability. Also, in any electrochemical cell like this, the membrane is the single most expensive component. So up to 30 to 40% of the cost. And so we've not only designed a system that has the potential for higher durability and longer lifetime, you've also removed the single most expensive component all at once. Right now this is in a prototype stage, this hydrogen bromine membraneless flow battery. We've devised a prototype and published a couple papers on it, and we're currently working on issues related to scaling it up and reversibility. But this is something we're very excited about. We're actively looking for partners and applying for grants, and this is something that if I had to guess, within the next year we might start a company around it. There's a huge market potential for devices like this, mainly in the area of energy storage. So energy storage is projected to be greater than $100 billion market within the next 5 years, and that's largely due to the expansion of renewables. So renewables like wind and solar. The problem with these renewables is that the sun shines when it wants to shine. So it's not really well timed with the demands of the grid. And so, if you could design storage mechanisms in order to kind of curb the intermittency of these renewable devices, it would be a huge value boost for renewable energy. So a lot of people say in order to get widespread renewables, we're absolutely going to need energy storage. And so the market for devices like the one that we propose, this hydrogen bromine membraneless flow battery, is tremendous.